Have you ever just wondered what it would be like to build a living, breathing world completely from scratch? Well, today we're diving into an incredible project that does exactly that, turning lines of Python code into a dynamic underwater world that's literally teeming with artificial life. Okay, let's just soak this in for a second. This one sentence really tells you everything you need to know. This isn't some big studio with a massive budget. Nope. This is all about the passion of one self-taught developer, driven by nothing more than pure curiosity to create something amazing from the ground up. So how in the world does a journey like that even start? It definitely doesn't happen overnight. Let's actually trace the developer's path, step by step, from a completely blank screen to a living, breathing digital ocean. What's so cool here is that you can see the power of just starting small. It didn't begin with super complex AI. It began with the absolute basics, the world itself. Then came the plants, then some simple fish. You see, each new feature was like another building block, another lesson learned, that created a solid foundation for the next, more complicated layer. Right, so before you can have any life, you obviously need a world for it to live in. And the foundation of this simulation isn't just some static backdrop, it's a completely dynamic environment. Let's take a look at how this digital canvas was painted, from the first pixels all the way up to the plants. And this slide just shows you we're not talking about a simple blue background here. This is a world with a real atmosphere. You've got these incredible volumetric light rays cutting through the water, giving it a real sense of depth. There's haze, there are ripples, and even the soil itself changes color depending on how many nutrients are in it. Every single element is designed to make this digital world feel truly alive. But the really crucial piece of the puzzle here is the closed-loop nutrient cycle. I mean, think about it. It's a totally self-sustaining system. Fish waste turns into particles which fertilize the soil. That enriched soil helps the plants grow. The plants then produce plankton, which, you guessed it, the fish eat. It's the perfect digital circle of life, running all on its own. So we have this beautiful living world. It's got physics, it's got ecology, but for now, it's empty. The next giant leap was to give it inhabitants, and not just simple animations, but creatures that could actually think for themselves. And to give these fish minds, the developer built a neural network from scratch for every single one. You can think of it like a tiny, simplified brain. It's not just following some pre-written script telling it what to do. No, it's actively taking in information from its world and deciding on its own how to react. So the whole process is this really elegant three-step loop: sense, think, act. The fish's sensors feed data into its brain, which is constantly weighing everything. Am I hungry? Is that a predator? Is that a potential mate? And then it just outputs a simple action. And over, these thousands of tiny little decisions start to compound into really complex behaviors, like schooling together or developing hunting patterns. Okay, for me, this is the most mind-blowing feature of the whole project. You can click on any fish in the simulation and see a live visualization of its brain working. You can literally watch the input neurons light up as it senses food and then see the output neurons fire to tell its body to move towards it. It's like having a direct window into the mind of an artificial creature. Just incredible. So we have this unbelievably detailed world, right? And we have these intelligent, thinking fish. What actually happens when you put all of those pieces together? Well, you get a true ecosystem, with everybody playing a specialized role. The common fish, they're the grazers, kind of the base of the food chain. The predators are the hunters, keeping the population from getting out of control. And the cleaner fish, they're the sanitation crew, recycling all the waste back into the environment. Each species has a very distinct job, and it creates this really delicate, beautiful balance. And this is where the real magic happens. The developer never coded a rule that said, hide in the kelp. They just programmed the fish with a simple instruction: flee from predators. But through trial and error, the fish's neural network learned that when it's inside a plant, the danger signals go down. That unplanned, intelligent-looking strategy is what we call emergent behavior. It wasn't programmed, it was discovered. I mean, this is already a stunning achievement for a hobby project, but it's also got so much potential. So you have to wonder, where could something like this go from here? Well, to see how this passion project stacks up to professional standards, its source code was actually run through an AI-driven analysis. So, what did it find? The analysis had a lot of praise for the project's overall organization, but it also flagged a few key areas for improvement. For example, it suggested refactoring the main fish.py file. Now, refactoring just means cleaning up and restructuring the code. Right now, it's what's known as a God object, one single file trying to do way too much, which makes it tough to manage. These are exactly the kinds of tweaks that can turn a creative prototype into a really robust piece of software. So, beyond just polishing the code, a whole separate analysis asked a really fascinating question. What if you took this incredible simulation and turned it into a game? And the concept they came up with is just brilliant. You don't control a single fish like a puppet. Instead, you become an ecosystem guardian. You influence the world, but not the creatures directly. You might sculpt the terrain to make new hiding spots, or introduce nutrients to see what kind of life flourishes. Your job isn't to command evolution, but to gently guide it.
Ultimately, this project is just such a powerful example of what's possible with passion and curiosity. It proves that by starting with simple rules and just building step by step, you can create something that blossoms into this beautiful, unpredictable, complex thing. And it really leaves you with just one question: what world would you build?